Welcome to This Explainer. Today we're diving into something that absolutely fascinates me. We're looking at questions that have mathematically flawless, yet completely contradictory answers. I mean, these are paradoxes that literally split some of the smartest people in the world right down the middle. So prepare to have your mind bent just a little bit, because we are getting into logic puzzles that literally break our understanding of reality.
All right, let's jump straight in. Picture this. You walk right into a room, sitting on a table is a box, and inside is $1,000, right out in the open. Next to it, a mystery box. Now standing nearby is a supercomputer, or maybe you can imagine it as an omniscient being that is incredibly, near perfectly accurate at predicting human behavior. And here's the kicker. It's already predicted exactly what you're going to do before you even step foot in the room.
So, this supercomputer gives you a choice. You can either take both boxes or just the mystery box. But here are the stakes, and they're huge. If the computer predicted you'd only take the mystery box, it already put $1 million inside it. But if it predicted you'd get greedy and grab both boxes, it put absolutely $0 in that mystery box. Remember, the computer made its prediction and set these boxes up way before you even arrived. So, what do?
Section 1. Newcomb's Box Dilemma. 1,000 or $1 million. This setup is famously known as Newcomb's paradox, and it was devised back in 1960. About a decade later, philosopher Robert Nozick pointed out the incredible psychological fracture this puzzle creates. To put that into perspective, look at this 2016 Guardian poll of over 30,000 people. It proves just how evenly divided humanity is on this exact question. Like 53.5% said they'd take just the mystery box, and 46.5% said they'd take both. You see, the solution feels so completely obvious to whoever's answering it that both sides think the other half of humanity is just being totally ridiculous. Let's look at the flawless logic driving each side. Okay, so if you choose only the mystery box, let's call it box B, you're relying on what's called expected utility. Basically, you're just playing the mathematical odds. Let's say this computer is 90% accurate. If you choose both boxes, 9 times out of 10, the computer predicted it, meaning the mystery box is totally empty and you walk away with just $1,000. But if you choose just box B, 9 times out of 10, you walk away with $1 million. Mathematically, an expected payoff of around $900,000 completely crushes an expected payoff of $100,000. It seems super obvious, right? Like, obviously, just take the mystery box.
But hold on a second. The two boxers completely disagree, and they use something called causal decision theory. They argue for strategic dominance, meaning no matter what the other guy does, this specific choice is always better. Look at it this way. The computer already made its choice, right? The money is either in the mystery box or it isn't. Your current thoughts absolutely cannot change the past. If the million is in there, taking both boxes gets you $1 million and $1,000. If it's not there, taking both gets you $1,000 instead of 0. No matter what, you are always $1,000 richer by taking both boxes. Two flawless arguments, two totally contradictory answers.
Section 2. The Sleeping Beauty Problem. Heads or tails?
Let's see how this logical divide builds with another deeply controversial puzzle. This one has generated literally hundreds of philosophy papers over the past 22 years. It really tests the very nature of how we perceive probability, and honestly, our own existence. Here are the strict experimental rules. A volunteer, let's call her Sleeping Beauty, agrees to be put to sleep on Sunday. The researchers flip a totally fair coin. If it lands on heads, they wake her up on Monday, then put her back to sleep. If it lands on tails, they wake her up on Monday, put her back to sleep, and then wake her up again on Tuesday. But crucially, every single time she's put back to sleep, she's given a drug that wipes all memories of any previous awakenings. So she never knows what day it is, or if she's already been woken up.
Every single time she wakes up, the researchers ask her one ultimate question. Given that you are awake, what do you believe is the probability that the coin came up heads? Really think about this for a second. What would you answer?
This brilliantly illustrates that divide all over again. The halfers out there say, well, it's a fair coin, she knew the rules beforehand, and she got 0 new information upon waking up. A fair coin is always 50-50, so the answer has to be 1/2. But the thirders argue that she actually did learn something. She learned she exists in a reality of 3 possible waking states: Monday heads, Monday tails, or Tuesday tails. Since heads is only one of those 3 states, the probability is actually 1/3. Wild, right? Let's break that third-year argument down with a quick analogy. Imagine a soccer game where a powerhouse team, like Brazil, plays Canada. Brazil has, say, an 80% chance of winning. If Brazil wins, researchers wake you up once. If Canada wins, they wake you up 30 times, wiping your memory each time. When you wake up, who do you guess won? Well, if you want to correctly pick the winner of the actual game, you guess Brazil.
But if you want to win the most bets during your interrogations, you should absolutely guess Canada, because you'll be asked 30 times if they win. It completely changes the math.
Section 3. Simulations and expected utility, scaling the paradox.
Now, I want you to hold on to that third-order logic, because when we scale it up, it leads us into some seriously mind-bending territory regarding the fundamental nature of our own reality. The thinking goes kind of like this. Human computing technology is improving at an astonishing rate, right? Eventually, it'll be trivial for us to create highly realistic simulations of our universe. And once we can do that, we won't just make one, we'll make unlimited copies of our universe. Therefore, if there is only one true base reality, but billions of simulated realities, the math overwhelmingly dictates that you are statistically far, far more likely to be inside a simulation right now than in the one true reality.
So, the crucial point here is this is just like the Sleeping Beauty problem but scaled to infinity. Imagine reaching into a huge bag with one white marble and a million black marbles. What are the actual chances you pull the white one? Basically zero. If a tails outcome, or in this specific case, a simulated universe, spawns a million conscious wake-ups, guessing heads or base reality suddenly seems entirely absurd.
Section 4. The power of pre-commitment. Rational irrationality.
So you might be wondering, does any of this actually matter outside of abstract philosophy? Well, yes. It quite literally dictates the survival of the human race. Let's see how expected utility and dominant strategies play out on the global stage. To ground this historically, let's look at the rapid escalation of the Cold War arms race. In 1949, the Soviet Union detonated its first nuclear bomb. By the mid-1960s, the U.S. had over 30,000 nuclear warheads and the USSR had over 6,000. Both sides had more than enough firepower to completely annihilate each other multiple times over.
The U.S. Secretary of Defense at the time, Robert McNamara, didn't push for disarmament. Instead, he pushed for mutually assured destruction, or MAD. The whole idea is that you pre-commit to total, horrific retaliation. If they launch, you launch, and absolutely everyone dies. It relies on the terrifying logic of the prisoner's dilemma. You see, in a one-off game, the rationally dominant strategy is always to defect, to betray the other person and attack to save yourself. So how on earth do you stop an attack?
Well, you do it through rational irrationality. In a one-off scenario, a completely rational person will defect to save themselves. But if everyone does that, society collapses. A rational society needs cooperators. Therefore, to survive an iterated game like human existence, you have to pre-commit to a rule that seems completely irrational in the short term. You publicly commit to the worst possible option, total global annihilation, to prevent the other side from making the rational choice to attack first. The commitment itself is the strategy.
These paradoxes really give us a kind of cognitive whiplash. They pit two completely flawless logical frameworks right against each other. The mathematician and poet Pete Hine summarized this beautiful confusion perfectly when he wrote, "A bit beyond perception's reach, I sometimes believe I see that life is two locked boxes, each containing the other's key."
Which brings us to the ultimate takeaway from this explainer. The real question isn't just how to act in the moment, but what kind of rules you ought to follow in life. If you were a robot, totally capable of wiring your own programming, what rules would you actually set for yourself? Would you wire yourself to be the kind of person who honors an ideal pre-commitment? Ask yourself right now, when the stakes are truly on the line, are you a one-boxer or a two-boxer?